Okay, I think it's on now. A few announcements. The attendance will start from today's session. So if anyone misses two session in a row, will be removed as we made it clear last time. Okay. We totally respect that today is Eid and some guys who are celebrating will not join. That's totally fine. But the next session is compulsory for them as well. If they do not, uh, you know, if they don't tell us in advance, then probably we will be out as well. So that's clear from my end. Let's start. Should we start? Let's just wait for one more minute, see if more people can join, and then we can start.
Okay, so Kahuna,
Oh,
meanwhile, you can explain
yeah.
what would be the today's plan, how you are
Just
going to
yeah.
proceed today.
I have one more announcement to make. Let me just see that. I just saw the questions tab. I would highly encourage everyone to actually go through the resources before the session and add your questions there, because we don't have any other way to see whether you are engaging with the materials or you are proactively joining the sessions or not. If you do it passively, then it's much better you watch our YouTube videos than really coming to the meeting. So that's gonna be much better for you and for us as well. So since it's first session, I would not take things too strictly, but I would highly encourage everyone to add questions, because that's the only way we can really measure how things are going. Okay, so let's start. I'm sharing my screen. Just give me another second. I don't want to share the whole screen. Just one mid window. Is it visible?
Yeah, it is visible.
Okay. Another thing. This is the first time we are doing PPT. We did not intend to do a slideshow. We just thought we would read it from the Google Docs. But then I got a suggestion from Sidra. I was running the whole presentation through her, and it was recommended that we do it this way. That would be much better. So it's a last moment decision that we did the PPT. So there will be few errors. Excuse me for that. So let's start. Since today's module one is related to semantic web and entity oriented search, we will look at five concepts. One is lexical search, another semantic search, uh, and we will see the comparisons between them. What was the need for the semantic search? Then the anatomy of an entity. Then we will look at entity attribute values, and then triples and knowledge graphs, and finally knowledge domains and contextual domains. You can already notice a few errors right in the first slide. Uh, shall we start? Okay. So first thing, lexical search. It's a traditional system, text-based search. So whenever a user searches something in the search bar, the search engine would take that exact string, either lemmaticize it, stamps it, and create different forms, and then exactly matches those words against the documents. Whoever, like whichever document contains those queries or keyword terms in certain locations, like title, H1, H2, H3 in the first 100 words, and so on, will be considered relevant. So it was an cost effective option. Now, characteristics: it matches exact characters, words, or phrases, and it uses inverted indexes and BM25 type algorithms to assign relevance. We will look at an example as well to see how it may uh, consider scoring relevance for the queries and documents and retrieve those results. Now, it can also stem or limitize the queries. So it can match the multiple variations of the query rather than strictly matching the exact keyword. It focuses on individual words, not underlying concepts or meanings. So it's directly a Boolean system where it will consider the presence of exact phrases in the document. Now, if someone is searching for a term which may have multiple meanings, like Apple, or like Apple, one is fruit and the another is tech company, so it will not be able to disambiguate those results. It will typically look for the presence of words, and there will be the presence of Apple in both type of documents. So higher chances it may return the results containing both. Now, results are traditionally ranked, sorted, and returned. So it looks at certain if else statements, like if it is present in title, it's relevant. It's present in first 100 words, it's relevant. In heading tags, it's relevant. So these kind of if else, and then if the document is using it too often, then it will consider a spam penalty as well. One risk is it can be manipulated, like even if it's the information is not really good, it can repeat those phrases again and again in key places and eventually rank for certain those keywords. How it works: first, search engine will receive the query, it will normalize. Normalization may include stemming and lemmatization. Then the search engine will traverse the inverted index, will try to map the query terms to the list of documents, and then it will score the relevance and eventually return and then rank those results. One example, just for example, if the user is searching lightweight hiking backpacks, the search engine will break down this keyword in three different things: lightweight, hiking, and backpacks, and also backpack to match multiple variations. Then it will look through all the documents. For our example, let's say we have three documents. One is document A, document B, and document C. Document A has the keyword in the title, and it's also giving good quality of information around this topic. Document B is using a synonym like rucksacks, but it does not have the exact query. And document C is a spammy page which uh, spams the keyword 100 times but does not have any quality information. So a lexical search will consider in the first stage document A and document C as the relevant because these have exact matches and document B is not having exact match. Then relevance score, since document A and C both have the keyword in title and they both have uh, multiple occurrence of that particular keyword in the document as well. So C will win here temporarily since it is spamming it more often. Then in the third stage, the search engine may choose to apply a penalty for spamming the keyword 100 times. So C will be demoted and finally A will rank. But the limitation is, even though document B has synonyms and is offering more quality information and facts, it may not rank. So the limitation is, whenever you are using synonym, it the lexical search will not consider it as relevant. It will. Okay, somebody has just can't see.
No, it's by mistake.
Okay. Uh, Then it may miss contextual misses. For example, if somebody is searching for weather related fatalities and there is a news reporting that says a biker has been killed in a storm, since fatality is not the direct match of killed, it will not consider it as relevant. Entity confusion, as we looked at it before, Apple as a fruit and Apple as a company would not be differentiated in lexical search since it's not looking at the context or the meaning behind it. Now, coming to the semantic search, it understands the user's actual context and intent. So, whenever user search something, it will look at the entity in the query and then will also look at its different user data like search history, locations, and will become aware of other contexts as well. It eventually searches for things, not like strings. So it's not matching strings, it's looking for things and then related attributes and facts around it. The whole web is organized in real world entities. Like one would be Apple Food, another would be Apple Company, or let's say Donald Trump, Elon Musk. So that's how when someone searches, it will look for those entities in the query and then eventually match based on those. We will look at an example as well for this. So it turns search engines into answering engines since they can easily understand the actual intent behind the queries and then they will map that intent to the documents in the corpus and eventually return the relevant document. Plus, they can also, uh, you know, extract exact relevant passages as well to answer. You all have probably seen the feature snippet thing. That's one example of that. Uh, the characteristics of semantic search, it's entity oriented and it's context and intent aware. Context comes from two particular things. One is the exact entity we are using and the surrounding text in the the documents, and another is user data, which is search history, locations, previous interactions, how they have interacted in different search sessions. Handles ambiguity because if someone is searching for Apple as a fruit and Apple as a company, those will have different contexts. Apple as a fruit will have more nutrition related information in the documents, and the search history of the user will also be indicating towards that. Apple as a company will talk about iPhone, MacBook Pro, and all those, so that will easily differentiate. It's based on soft matching of queries. It's not exactly looking for the exact keywords, more of related contextually relevant terms. And when those matches, we say it's relevant. It's language agnostic since it's based on entities, concepts, which will mean the same thing in all the languages. The last thing, probabilistic and built on uncertain inference. Search engine knows and admits that they may not get the intent 100% right in each case. So they look at multiple intents behind the query and try to satisfy all those in those 10 uh, links that search engines will return. Core semantic search techniques. One is natural language processing. So it's it's based on artificial intelligence and machine learning. It requires it requires to pass the text and understand the actual meaning behind it based on multiple factors. We will not go in deep in all those techniques since we are not engineering search. We will just look at how things work. Named entity recognition. It checks for the exact entity in the query and then matches the documents or based on the context and the entity. Vector space models and embeddings. So all the documents and web corpus have been turned into embeddings by semantic search. So it's a mathematical representation of the meaning. So it will give a certain meaning and it's a multi-dimensional space. I can show one example as well here, how it looks. Let me just see. So this is how a vector space embedding would look like. If I search here Sue, you will see Sue's. And if I isolate, so that's it. What it looks like, a multi-dimensional space where if I choose Sue's, we will get all the different values of relevance, like what's the most relevant thing. And these relevance scores are coming from co-occurrences rather than dictionary meaning. So if more documents and more users are connecting shoes with clothes or shoes with dress, shirt, so that's going to be more relevant. Let's go back to the search. Okay, then knowledge graphs. It is an efficient technique to uh, represent the facts in a graph structure. In computer science, graph is basically where you have one node, another node, and then you represent the edges with the relationship. So let's say Donald Trump is a president, is the president of United States. So Donald Trump and United States is the entity here, and is the president of is the relation. So that's how it connects in the mathematical space. Dual encoders, so it can it's a dual tower based encoders. One can encode the searches and the another can have different documents. Once they encode the information, then they match mathematically. If it's relevant, they retrieve it. And then historical and stateful memory, search engine can always have access to users past searches and interactions with the results, and based on that they can re-rank certain documents that they think the user will like and eventually satisfy its need. How it works: first, query parsing and augmentation. So whatever you search, it will be augmented based on synonyms, lexical relations. So it, like for example, if you search for golden retriever, can look for large breed dogs. That's another one synonym that it can replace it with, and then search. So it's not gonna require that every document needs to have golden retriever spammed across the page. Encoding and neural matching. So as we saw in the vector space embedding model diagram, it will have the exact meaning, and based on that also the documents will also have the correct embedding. It will see the similarity between those and match the relevance. Information extraction and passage ranking. So whenever a document is found relevant, search engine can actually extract the exact heading and the passage under it for direct extraction and satisfying the need of the user. Now, re-ranking. Re-ranking may happen based on multiple things. We will go in depth in the module 3. But for now, you can see it. Initial ranking is when it's based on your content and how efficiently you have used certain phrases, contextually relevant phrases in your content. Basically, distributional semantics. De-ranking can happen based on user interaction. If user is having good interaction with certain URLs, the position gets solidified for those documents. Let's look at one example. Best food for an aging golden retriever. First thing a search engine may do is getting the entity right, which is golden retriever here. And it can also look for, let's say, food. Food can be translated into dog food, kibble, and aging can be translated or switched to having age of 8 years or more or senior dogs. Now it looks for mathematical matching. So it's turned on, yeah. Optimal diet for senior large breed dogs. So based on mathematical embeddings, it can also match the query to this particular document with title optimal diet for senior large breed dogs, where the food has been translated to transformed to diet, aging to senior, and golden retriever to large breed dogs. Now, scanning for semantic vocabulary. Since we are talking about food, diet for aging golden retriever, we need to satisfy all these intents as well, like joint support, the issues that an old or senior dog might have. So we will need to cover all those contexts in our document to be really relevant. We will see more examples of this in contextual domain and knowledge domain section. Now, if our document or of our source is giving facts, the Google will look at those facts and compare it against the experts that it considers in that particular knowledge domain. And if we are in that particular truth range or consensus, we will be preferred as well. So if you are, let's say the experts recommend that the diet must have high calcium, and we end up recommending that it must have high vitamin, then it's deviating from the exact uh, consensus. So that would not be considered as relevant by search engines. Now moving on to the entity. Entity is a concept. It's not just a string. It is language agnostic, which simply means the language does not affect the meaning of it. It exists independently, irrespective of a search query. It has dynamic and identity because with certain attributes, it can change uh, its meaning, its meaning as well. And there are like an entity can have multiple relations with certain entities as well in certain contexts. For example, uh, Donald Trump is the president of the United States. Donald Trump is also the host of the show Apprentice. So Donald Trump is related to the show Apprentice and United States both at the same time. So that's the mathematical model where a node can have multiple relations, and, and entities evolve with those relations as the relations keep building on. Entity types. There are a few entity types, for example, person, place, organization, song, movie, product, or language. One entity can have multiple types at the same time. For example, George Washington, he was president of the United States, so that's one. As a person, it could be military figure as well, and it was also an activist as well. Typically, if you traverse back, they all will come from the person entity type as well. Search engines use entity types to match queries to the most relevant answers. So, for example, if a query is requiring temperature, then search engine will match that to a value of entity type Celsius or Fahrenheit. Coming to the next entity classes, these are kind of categories of entities, specific entities, so kind of hypernym. They group similar entities based on attribute values and eventually form ontologies. So, for example, when we say singers, then we can talk about, let's say, Taylor Swift, or that's one instance of the singers, or Kanye West. So, specific instances all will become to this particular class. Entity associations. Entities connect to each other in the form of uh, triples, which is subject, predicate, object structure. So, X entity is a Y, or X entity has Y, or X entity does Y. So these three types of relations exist. Contextual connections between entities are driven by shared attributes. For example, if a movie, if there is a movie and we say who are the actors or who was the cast of that movie, then we will see multiple entities sharing that particular attribute. And if we trace back and from those actors point of view, if we get the value of attribute like acted in movies, so all those will share that particular entity connection with that particular movie. Semantic web knowledge graphs are found by this association. Since, as we talked before, an entity can have multiple relations with other multiple entities. Eventually, this all become a cluster in semantics in the mathematical space and eventually form a graphical structure. Uh, in computer science, whoever is from computer science can easily understand that it looks typically like this, but it's you just multiply it by n times and you will have a quite big cluster of nodes and edges. Semantic distance: if an entity is having multiple relations in multiple shared attributes, then those two entities are considered semantically close or relevant, since the connections are too many in and they are sharing multiple contextual domains as well. Entity attributes and types. Entity attributes simply means properties, dimensions, descriptive factors that define an entity. A few examples of types are: one is root, rare, and unique attributes. Root attributes are those which are shared by all the instances of an entity class. So, for example, if we talk about entity class as cities, then all the cities will have an attribute like population. Will also have total area. So these are root attributes that are present in all the instances. Rare attributes are those that are present in certain number of instances. For example, in the same example of cities, we can say there will be less number of cities who which has nuclear reactors or which has uh, you know any political building. So that's the rare. It's basically shared by a small group of entities under a entity class. Unique attribute is basically something that's shared by one particular instance of an entity class. Structural attributes defines like there are two more attribute types based on structure. One is simple, another is composite. Simple attributes are those which do not need to be broken down in further values. For example, population, it will have a direct value number. Composite, that can be broken down in further attributes. For example, size. Size can be broken down in height and width. And there are direct or indirect attributes as well. Direct attributes are shared by the entity itself. For example, area. Indirect attributes are basically the attribute of one of the properties. So you can say if there is an like New York City, New York City's attribute would be mayor, and then we can derive one more attribute from there, like political affiliation of that mayor. So political affiliation or political party that's ruling will be considered indirect attribute of New York City. Single valued or multi-valued. Single valued, again, population, straight single number. Multi-valued, let's say there's an in New York City we can say popular buildings, so that would have multiple values. Stored attributes are those that are exactly stored in the knowledge base. For example, uh, someone's date of birth. And derived attributes are that are calculated. For example, age. So age can always be calculated if you have the date of birth and the current year. Let's just consider this example, and then we can have a 10-minute break, and we can ask questions or see if we have to discuss something else. New York City example. The entity is New York City. Its entity type is place, location, entity class, city, or we can also say cities in the United States or US cities. Entity associations, we can see Statue of Liberty is located in New York City. So that's the association. Woody Allen has hometown in New York City. Now let's look at a few attributes. Root attributes would be population, geographic coordinates, total land area. Rare attributes would be underground subway system, since not every city has that. Stock exchange, skyscrapers. Unique attributes would be Statue of Liberty, Times Square, Central Park, since these are not present in all the cities. Simple attributes would be foundation year, since it cannot be broken down in further attributes. Composite attributes would be geographic coordinates, since it can be broken down in longitude and latitude. Direct attributes, total population, geographic area. Indirect attributes would be size of Yankee Stadium, since Yankee Stadium is an attribute of New York City. And then if we talk about size, it would be considered indirectly the attribute of uh, New York City. Single valued current mayor, multi-valued attributes, professional sports teams, languages, nicknames, top celebrities living in New York City. Total population, total area, and derived will be population density, since it will be derived from total population and total area, and city age. Let's see if we have any question. Anyone has any question? Anything to add? Yeah, go ahead, Purti.
Yeah, hi Kahuna. Thanks for explaining so many things in so much details. The doubt that I have is the one where you showed the graph, like when you search a word and then it shows like which other category it is, like the shoes, which other category it is associated with, right? How can we like which tool we can use to see those things, like where the word is associated with other things?
Look for somebody is echoing my own sound. The thing is this, you cannot use any certain tool while you are writing or optimizing for semantic search. These are for conceptual understanding. Eventually, we will rely on Google's own understanding, and we will show you the ways when we are doing practicals. It's again, one thing is you cannot know everything precisely. It's all relative. So you will see like whether semantic distance between shoes and clothing is greater than shoes and shirt. You can find that, but not with 100% precision. So for conceptual understanding and giving a mental image, these things are good.
Okay, thank you.
Yeah, go ahead.
I'd like to ask regarding semantic ripples, in which a sentence ideally should follow the subject, predicate, and object structure. I've been reading some semantic SEO articles that are optimized for semantic SEO, and most of them follow these sentence structures or semantic ripple structures. But what uh, but would it be okay if we maybe make the sentence structure more complex, if that makes sense, not following like the rigid structure of, let's say, subject, predicate, object, but it still has that, but the sentence is more complex in a sense. So yeah.
So you can have nested triples. So, in one sentence, you can represent two triples. That's fine. But if you are not
Mm,
representing those in a clear manner, then eventually you will increase the cost of computation. Search
mm.
engines would have to, understand the references of certain entities. And if you are using too many pronouns in one sentence, then it will be tough for them to resolve all those without having without having certainty.
I see.
So that's the
And
issue.
is that why in one of the videos that I watched from Korea, he said that sometimes he removes the word also in like sentence structures. Is that one reason why we should be as direct as possible when conveying information or when writing, so that it can help reduce the computational costs and just try to focus on like the information.
Yeah. Uh, that will come under again. That will come under the writing principles, but we usually try to reduce the use of non-contextual phrases which are not contextually relevant to certain things. The contextual domain we are writing in. So that's why the also is removed. There are other things as well that are being removed as well.
I see. Okay, thank you.
Anything else before I move on? The next, I think there are two more things to cover. Does anyone have anything to add or ask? Okay, let's move on to the next two more concepts. Five concepts in 30 minutes. Too much for everyone. Okay, let's continue with the EAV model as it's another name for triples. It shifts focus from strings and it's more focused on entities, things, and it's again, as we discussed, it's a very efficient way of representing the knowledge in mathematical space. Modern search engines structure their indexes around real world concepts. We will see it in knowledge domain and contextual domain topic as well. It's a foundational logic for fact repositories like knowledge graphs, since it's much easier to structure the whole graph structure. When I say graph, it means the computational data structure, which simply means having one node, another node, and then one particular edge connecting them with a shared attribute, as we saw in the embedding diagram. The triple, it basically has one subject, predicate, and object format. You can also have nested triples as well in one sentence, as I mentioned it before. The entity is the subject. It's representing the actual thing that we're talking about. Attribute acts as the predicate. It defines the relationship with the object that you're going to talk about in that particular triple. And the object is the final data point, that specific thing that you're connecting to. So one example, which again I will say, President Donald Trump is the president of the United States. So in that, Donald Trump is the subject, is the president of. This is the predicate, and United States would be the object. The attribute would define the relationship, which is being the president of US. Now processing EAV data. Neural matching maps EAV query triples to extracted facts. So for example, if someone is searching for who is the president of the United States, since they already have the attribute and the object, it's inquiring about the subject, which the answer is Donald Trump, it can easily match those things to the extracted facts since document will be mentioning all those facts. Search engine does not have to rely on vocabulary matching. It can understand. Okay, so let's say if some documents are mentioning the word POTUS rather than saying President of the United States, it can still retrieve those documents and consider them as relevant. It allows search engine to improve the understanding and intent. Yes, and it can actually understand the long tail queries that people are searching much better than the lexical search engine. Allows for complex interconnected logical trees, deep traversal, as we saw in the that model where we saw multiple connections in the space. Actual knowledge graph or information graph is much more complex than this, but it's for algorithms or for algorithms it gets much easier to traverse those and actually identify the exact facts. I think we have already covered it, so I will just quickly go through it. The main thing is having subject, predicate, and object. One example is Tom Hanks acted in and Green Mile. So Green Mile is the object, acted in is the predicate, and Tom Hanks is the subject. Knowledge bases versus graphs. Knowledge bases are basically massive fact repositories. They are not well structured. The graph is a data structure that is implemented to represent the facts in the facts of the knowledge bases. So it organizes the raw data into interconnected nodes. Like I think this is a good visual example how things can be connected. And every knowledge graph is inherently a knowledge base, but not every knowledge base is a knowledge graph since it's not well represented. Building knowledge graphs. Since triples interlock through common entities and relationships, as we saw, Tom Hanks acted in Green Mile. Then we can also say Tom Hanks acted in another movie. And let's say if we have 10 movies like that, then all those 10 movies are also connected with one attribute, which is cast, because all those movies will have Tom Hanks in their cast. And let's say if all those 10 movies are high grossers, then another attribute would be high grossers movie of Tom Hanks, and few names will pop up in those in the values of that attribute. One entity connects to many others through different edges, as we saw before. President Donald Trump can connect to US, to apprentice, to his wife, and many other. Now, surrounding predicates clarify an entity's exact context. Like, for example, as we saw before, Tom Hanks acted in Green Mile. That tells us that we are talking, we are processing Tom Hanks from the angle of movies that he has worked in. Inverse tuples or triples create bidirectional pathways to enrich the graph. So, since we have a triple like Tom Hanks acted in Green Mile, it can also be reversed or inversed to say that Green Mile's cast had Tom Hanks. So that's also a fact that goes bidirectional. Now, semantic SEO applications. Knowledge-based trust is built by providing accurate, unique triples. So if your source, your website keeps doing that, giving accurate information and again through multiple articles, you may get considered for as an expert source, and eventually search engine may refer to you for extracting the facts. Semantic SEO uses interconnected content networks instead of isolated pages. So that's the same idea. We also call our pages as nodes, and then all the nodes, all the pages are connected through certain contextual connections. Could be link with links, without links as well. Entity disambiguation, since different entities are connected to each other in a at in different shared attributes, it's much easier to see and differentiate what user is meaning by certain entities when they are searching in their with their query. We can use schema or structured data to give search engine uh, exact triple sorry exact triple like in schema. Whoever has, like, I think someone, you guys have experience with the structured data schema. There is always one in the JSON data, one is at property, and then we go with the value. So that's very efficient for machines to understand. Organizing data around entities help answer complex multi-part queries. So let's say if someone is searching for Starbucks near San Francisco, there are two entities here. Google can look in, check the locations of all the Starbucks, check whichever is near to San Francisco, and retrieve those results for the user. Coming to the last part, contextual domain and knowledge domain and contextual domains. Search engines organize concepts and disambiguate meaning using frameworks. So all the entities or certain create the knowledge domains from the whole universe of web corpus. So Apple as a fruit will have its own knowledge domain. Fruit itself will have its own knowledge domain as well. Contextual domain is basically a lens or point of view through which we process those knowledge domain uh, on our website. Not every website will cover the same entity with same context. So, for example, uh, if you have a website which is an e-commerce for shoes, that will cover shoes in a different way than a manufacturer who is manufacturing the shoe. So he will focus more on production. We'll talk about those attributes, leather and all those. And e-com would focus on sizes, uh, different styles, fashions. Knowledge domains. It's overarching universe of topic. It can contain all the queries, entities, search patterns, user data, different sources that it qualifies. For example, some sources can be qualified as expert, other set of sources can be qualified as laypersons. It can also have layouts, different functional elements, and the scale of a knowledge domain could be that it could have millions of entities and billions of facts. Knowledge domains are language agnostic, built on shared concepts, as these are built on entities, and entities are language agnostic as well. So it doesn't matter whether you are searching in Spanish or English, the knowledge domain of neuroscience will remain the same in both of those languages. Contextual domains are a specific viewpoint applied to those knowledge domains. They combine a knowledge domain with a context qualifier. Qualifiers could be adjectives, adverbs, prepositions. Adding a single qualifier word can entirely shift the whole domain. We will look at some examples to see how this works. Now, search engines evaluate sources based on these specific processing angles. And for a website, these angles are determined by source context. We will look at the source context later on, probably in module 4. Last thing, having contextual layers, a hyper-specific subdivision. It's a subdivision of the contextual domain. It uses subqualifier to focus on further specific meanings. It has the same knowledge domain and it's playing in the same contextual domain as well. Represents highly specific, valuable long tail search queries. I have an example or not? I forgot to have an example. Anyways, let me give you an example. Let's say the knowledge domain is innovation, and if we add innovation plus X industry, for example, automobile industry, so innovation in the automobile industry would become contextual domain. Now, if I add one more qualifier there, let's say innovation in the automobile industry in US, that will become another contextual layer in the contextual domain of innovation in the automobile industry. Another contextual domain example could be innovation in the construction company, or let's say in the knowledge domain of fruits, we can say useful fruits for children. That would become your contextual domain. And if we say useful fruits for children with insomnia or anxiety, that would become further contextual layer. And if you want to go deeper, then obviously we can say useful fruits for children with anxiety over 6 year old. That's further deep. Context alters an entity's identity and truth range. So certain contexts, as we discussed before, how you process, let's say an e-com would write differently about shoes than a manufacturer of that particular shoe. Attribute prominence shifts based on entity's domain, as in, let's say, innovation in automobile industry itself is a knowledge domain, but since we are having the relationship, we are exploring the relationship from the context of innovation. So it changes how we're going to talk about automobile industry. For example, the Apple entity changes meaning across domains. In fruit, it will have different. In tech, it would have a different meaning. A website must prioritize attributes that align with its context. Here, with the phrase its context, we mean source context. As we mentioned before, an e-com source would process the source differently than a manufacturing company. Final slide. SEO importance, achieving topical authority. We try to uh, enter into as we would like to enter into as many sub indexes of different contextual of the whole knowledge domain. Just a 1 minute. Apologies for disturbance. Just someone was knocking at the door. Context specifying as sharpening. Contextual domains will be helpful in doing so, since each contextual domain has its own list of phrases to that we can use to specify or sharpen the context and stay in that particular contextual domain rather than going into different for and if we go into different contextual domains in one article, that will dilute our ranking signals, will create confusion for the algorithms. Preventing cannibalization, we will create each document focusing on one particular contextual domain, and we will remain in that. We will still establish different connections with other contextual domains through our supplementary content, but not in the main content where we are answering the macro context. Building knowledge based trust. Since our website will cover all the contextual domain under a certain knowledge domain that are relevant to our source context, we will be able to act as a knowledge base. And if we provide enough facts regularly and provide quality information through easy to understand semantic triples for algorithms, we will have a better cost of retrieval and will eventually be considered as an expert or the authority. So I think that's all for this presentation. I think Behzad has something to add. Go ahead before everyone can ask.
Okay, so thank you so much, Kahuna. That was a great presentation. I didn't think that you will go so deep in this short session. So it was all theoretical plus practical examples for better understanding of all these basic things. All these things are theoretical, but the main purpose here is to share the overall basic layer for semantic SEO's understanding. So I just requested Kahuna, let me allow to share a different perspective and other perspective. I am not going to go in much depth about the concepts and all these things. I am just going through within 5 to 10 minutes, just a quick revision what Kahuna has shared with you guys. And I would add just some practical examples or some research studies or some patents references, because what we have discussed in this module first, we will not repeat this in any other module. What has been shared in this module for knowledge purpose, for base or foundation building, will not be covered in any other module. So you need to strengthen your foundation from this module. So I am just going to add some practical perspective for you guys to explore more things. So first subsection here is semantic search versus lexical search. The lexical search is based on phrase match. Phrase match indexing. So search engine founds the string user searched for best Nike shoes for seniors. Once searchers search this on the sub results, search engine will see which documents contain this exact phrase or the combination of individual words with the change of position. But it will not try to understand the search intent. It will not try to understand the context. It will not try to understand the overall related synonyms or the contextual entities to find in the responsive documents. So if you want to explore more about the lexical search, and do remember, now this is the age of semantic search. After 16th May 2012, the announcement of things not strings introduction to knowledge graph. So after this announcement, search engine has become a full semantic web that focuses on entities, user intents, and the connections of entities with their attributes. But still in the age of semantic search, search engine also works lexically. It is working parallel for both contexts, both streams. If you want to know more about lexical search or phrase-based indexing, so you can read Patents by Anna Lane Patterson or Anna L. Patterson. Yes. So she is a patent inventor in Google. She has two Google patents regarding phrase-based indexing and phrase-based searching. So it will help you understand how search engine is relying on phrases used in your content. So first is phrase-based searching, Google patent, and the second Google patent, phrase-based indexing. How search engines are utilizing exact phrases, your target keywords for uh, search engine searches. So the search is query parsing. When a user searches a query, search engine parses each word to understand its context and its meaning. So it is processed. So the understanding level of a search query by the algorithms is a query parsing phase, And when search engine has understood, okay, searcher is looking for this item, it starts looking the responsive documents that are more suitable to answer the searched query. That step is called query processing. You can read Google Core slides from SlideShare regarding query parsing for semantic search engine or semantic web. It contains all the details. So it is about lexical searches. It is based on exact keywords. Search engine is still utilizing it. There are multiple techniques used by search engine to identify the exact phrases and to focus on distributional semantics based on the exact phrases. And you have seen that lexical search doesn't include the context. It is based on the exact words from the search query. And you already know, everyone speaks about it. Semantic search is all about meanings, context, and intent. So I am not going deeper here. I shared some resources and all these things entities in retrieval information needs. So enhancing the search experience, query fan out that is related to AI overviews, LLMs, responses, and citations. It is all about intent disambiguation and query augmentation. Query augmentation is very, very, very important concept. There is a particular Google patent named as query augmentation, and Core has also many social media posts and one or two research study and different videos talk about query augmentation, and we will see it in the uh, five fundamentals of topical map. It is central search intent, where we try to augment user intent. So all these things are related. Historical and stateful memory, it is all about nav boost, user history, user search data, and there is the Google patent context based search engine, search ranking, context based, sorry, user context based document ranking, user context based document ranking. This Google patent mentions how search engines look at each activity of a searcher before showing the results. So first they try to understand what is the historical data of a particular searcher, what he has already searched in his browser, and then based on that history, they rank documents. So all these things are important. I mentioned this one. So this is the official announcement of semantic web knowledge graph reputation. They started to understand the things, the real world entities that are the noun values in the real world that are language agnostic. And what is semantic search? This is the latest post from Google regarding semantic search. So it is a very hyped topic. So search engine is also rephrasing the main concept again and again, iterating over the basics. So don't miss these resources. The time is limited. We can't go in depth in all these individual blog posts, but everyone who is interested to engrave these concepts must understand these things. So this is a Google patent. That's a very, very important because it is based on user context based search engine. You will see the concepts spread all over the practical steps from this Google patent. And there is a easy summary, simplified summary for this patent. You can read it, and all these resources, you can schedule these resources in your upcoming weekends so that every weekend you go aggressive for semantic SEO learning. So these resources were compulsory. You need to understand these resources. And the next item is anatomy of entity. So why to understand entity is important? Because when you are providing the content, you need to understand what is my target entity and how I need to augment its context. So defining entities, conceptual versus physical, all these details Kahuna has shared in very much detail. So entity types, there are entity types. So you need to understand when you are writing on one entity type, you need to cover the most prominent named entities for that particular entity type. And sometimes we want to rank for one entity type in our document. So it means we need to cover all the required named entities for that particular entity type. So if we are mentioning person in specific context, so we need to provide specific named entities that are prominent in that particular context. And now entity classes you have well understood from Kahuna's examples. I am missing it, entity associations. So this is the main thing why we are putting so much focus on entities and semantic triples, EAV model, all these things. So all this shit is about conveying your message to algorithms, because algorithms are understanding entities. Entities are real world nouns that has been recognized by the search engines. If a noun has not been recognized by search engine, it is not an entity. Every entity is a noun, but every noun is not an entity. So we need to provide the entities relations in a simplest format, and that simplest format in English language or English grammar is semantic triples. A is B, subject, predicate, object. This subject and predicate both are, these are the entities. So predicate is the contextually combining unit that is expressing the relationship between subject and the object. And if you want to understand why Kahuna has 3, 4, 5 slides for semantic triples and then EAV model, you need to read knowledge based trust. Knowledge based trust research paper from Google. This individual paper explains search engines calculate trustworthiness of web sources based on the information provided through semantic triples. This paper explicitly explains that the document that explains information in semantic triples has a high quality signals than the document that is not providing information in right semantic triples. So that document is very important to understand and read regarding the importance of semantic triples and EAV models. Why we are so much interested and why we are so much concerned in semantic SEO for semantic triples. And the next item, so all these things, context shifting, you have understood very well. So this is the Core's. No, this is from my YouTube channel. You can watch, but if you have understanding of basics, you can skip it. And it is from Core's. So you must go through this 1 hour video. And the next one is entity attribute value. I have explained why we are so much concerned about the entity attribute value. So here is the difference of types of attributes. Why we are loving these attributes? Because entities are recognized through their attributes. Like if we want to mention Apple Tech Company, we need to provide Apple's attributes regarding its tech company. We need to mention iPhone, we need to mention iMac, we need to mention MacBook. But if we are mentioning Apple as a fruit, we need to mention its fruit related attributes. So with the help of right attributes, we build the proper context. And the next item, we have understood all these types very well. So some resources from Core and then triples and knowledge graph. And another perspective of semantic triples is that search engine stores information in its knowledge graph in the form of semantic triples. So A and B are two entities, let's assume. A and B are two entities. What is the relationship between these two entities? So A is the son of B. So the relationship between A and B entities is the father and son relationship. So search engine will connect these two nodes, two entities with the help of one edge, and edge shows the relationship. So this is why we need to provide everything in a semantic triple format so that search engine can understand what we are talking about, to which knowledge domain, to which contextual domain, to which contextual layer the information resonates that we are providing in our documents. So all these examples are here. Knowledge bases versus knowledge graphs, context shifting, fact extraction, and easiest example to understand knowledge domain, contextual domains, and contextual layers. Fitness is a knowledge domain in which every type of fitness related information will be covered. So it is a universe of information. Knowledge domain has two, three characteristics. Number one, it has a particular audience cluster. It has a particular query cluster. It has a particular document cluster. When all these things are provided, it becomes a knowledge domain. So someone is there to search for that information. So there are some queries regarding that information, and there are some resources that are providing information for those queries. So when all these three are available, so it is a knowledge domain. Fitness is a knowledge domain. And when we add one attribute of fitness or one entity, calculation, this is one word, but it specifies a one contextual domain within the whole knowledge domain of fitness. So fitness calculators become a contextual domain. So when we deep dive into contextual domain of fitness calculators, there are multiple contextual layers. So one contextual layer is BMI calculator, fitness calculator for BMI, fitness calculator for BMR. So individual calculators are the examples of contextual layers of fitness knowledge domain. And the main thing is why we are so much concerned about these things and why we need to understand knowledge domains, contextual domains, and contextual layers. Because whenever we are providing information, we must know what was the parent topic. Lexical relations, we need to understand lexical semantics. And Sir Kore has one detailed case study about the verbs of life, the lexical semantics importance. A detailed case study, a huge knowledge base is there. So you must read to understand these things. So we need to understand what are the parent topics, what particular knowledge domain my target topic relates, and what are the subtopics or the contextual layers of my target contextual domain. If I am in a particular contextual domain, I need to understand what are the prominent contextual layers for which I need to provide information on my website. So next item, knowledge and contextual domain. I have already discussed all these things. So it was all about the module one. We have covered the minimum level of the semantic web and entity oriented search. So let's move on the questions. So the first question, a few questions from starting I will cover, and then we will take help from Kahuna. Yes, Kahuna.
I think we have already reached the time limit. Let's just ask everyone if they are available. Otherwise, we may have to end it right now. So please respond in the chat. Who is available for next 15-20 minutes to cover these questions? Just do it quickly. 5 responses available. Was available. We have 21 submitted to. Okay, we will keep it under 20. Anyone else? Any? I don't think everyone has responded. I will hear you from my phone. Great. As long as you hear us. Okay, let's go ahead.
Thank you. Bye. Sorry. Bye bye.
Okay, no worries.
Okay, so we have first
Go ahead.
question. How do I manually analyze sub data to identify key entity properties, attributes, types, and relationships without going overboard while optimizing for information gain? And is focusing. So the second question is, so I tested Behzad AI tool, which is awesome. Okay, that's great to know. But I was wondering how I could better pair my own analysis with the results from AI. So it all boils down to your subject matter expertise. So first of all, you need to enhance your personal knowledge base. You need to understand your niche in a better way so that when AI analyzes the SERP results, you must have some prior data in your mind to understand to get more from the SERP and leave the AI tools. You need to evaluate SERP results with the naked eye, without any AI tool. You must understand what SERP is explaining. So if you are in a new niche, so it is better to first understand AI analysis, and when you have some knowledge, then do manual SERP analysis. Start with bolded terms. Each word, each bit and byte on the SERP results is relevant. Each word on sub result on first page is important. Now it is your perspective, it's your understanding how you classify which information is for immediate use and which information is a related information for micro context or the related topics suggestion from search engine. Whenever you search a topic on the sub, there is 90% chances search engine will show some related topics to you, and there will be some resources that will be covering broader topics. So it is a suggestion for you that this topic belongs to this broader topic. So if you are covering this small topic, you also need to cover that broader topic on your website. So all these related information signals are from search engine result page. So first of all, try to understand body terms, and then try to understand meta descriptions, and one phrase we call it quality terms. From the sub results, try to understand quality terms and try to augment their intent. If there is a word now, ordered now, it means it reflects 24 by 7 business availability. If it shows 24 by 7, it means it is evident that you need to respond to clients 24 hours. So there is a one word, but it has a whole context behind it regarding that particular niche. So when you deep dive in this way, you will understand it better. And then is focusing on the first page of sub sufficient, or are there any external or specific data sources to consider? So it all depends on what is your purpose of doing self analysis. If you are creating a content brief or you are planning to write a content page for a particular topic, then sub data is just one aspect of information collection. Search engine sub result is a reflection of search engine's knowledge base and knowledge graph. But you can see how much information can be presented on a first page. So there is a great limitation, information limitation. So Be assured, be be confirmed that this is just a slight picture of the whole topic. You need other information too. So you need query semantics. You need to understand user queries from SEO keywords, from SEO tools. You need to understand those. You need to augment intents through social media topics, ranking for your target queries. You need to augment image search results to understand what are the visual semantics elements ranking in the image searches. You need to, if it is a newsworthy content, you need to go to news tab to understand are there any particular fresh news information. You need to go to forums tab to understand what is going on the forums regarding this particular topic. So SERP analysis is just a one step to take a good start for your semantic analysis. Then the second question is the successful metric for entity optimization obtaining a KGM ID? And if I am doing SEO for an organization, what roadmap should I implement to strengthen its entity? So I assume it is strengthen its brand entity. So brand entity is all about optimizing your brand entity's presence with the help of right attributes. So just remember one sentence from Jason Bernard: search engine is a child that understands through iteration. You need to repeat your information. You need to repeat your brand's identity in the form of semantic triples all over the internet. Spam the internet with your right information. Every source, every authoritative platform, every social media post must declare your brand attributes in the form of semantic triples. Why semantic triples? Because algorithms understand the semantic triples. This is the language. And one thing Kahuna mentioned, schema markup structured data is the best of the best way to communicate information in the form of semantic triples. So there is always a schema type that has multiple schema properties. So schema type is the main entity for which we are trying to explain the attributes, or the schema properties help us to show the values of our attributes in the perfect semantic triple format. And if you dive deep into schema markup, you will try to understand and you will come to a result why four search engines collaborate to build schema markup: Yahoo, Bing, Google, and Yandex. These four search engines collaborated for a single mission to build one universally recognizable language in JSON LD format with a shared or a fixed vocabulary. The purpose was to translate information in the form of semantic triples. So schema vocabulary is the very type vocabulary, fixed schema properties. I can't add more schema properties if there are not available on the schema.org website. So fixed vocabulary and fixed format, very strict rules. If you miss one comma, whole code will break. Algorithms will refuse to understand. If you miss one inverted commas, tools will be failed to understand the whole schema markup. So it is very tighten environment. Why? Because they want information in optimized semantic triple format. So all these things are the supplementary. Successful metric is to understand the brand popularity. The ultimate goal is to increase brand searches. Whatever your brand popularity is, if your target audience is not searching branded queries, If your brand doesn't have branded searches, it will not have a big impact. So you need to be visible to your audience so that they can search brand plus their need. There is a Google patent from Stephen D. Baker that is website quality predicting site quality. Predicting site quality. It is about n-grams, and another patent is about site quality score. Site quality score by Stephen D. Baker. This patent is all about measuring the branded queries. Site quality score. I am just going to make sure I am not referencing the wrong engineer patent, and it is from who is the inventor? Either it is David C. Taylor. Oh, sorry, it is Navneet Panda. Navneet Panda is the Google engineer behind Panda Update 2013. So what that update did, that update was a crackdown on spammy backlinks. They started to evaluate individual brand related quality signals to score the website's qualities. So they said we can't over rely on the backlinks coming to a website. So they started to evaluate a website's quality through the branded search queries or navigational queries where user put the brand name in a search query. Brand query to the particular site. This patent mentions two dimensions site quality. Number one, how many branded searches are there for a particular brand? One quality signal. And then how much is the click satisfaction for the results shown against the branded search queries? So these two things are the main factors through which search engine decides whether this website is a qualitative website or not. So what is the quality of a website? So Navneet Panda is very important to understand, and Navneet Panda's whole work is around determining site quality. And another Google patent from Navneet Panda is predicting site quality. Predicting site quality. So it is based on n-grams analysis whether a new website contains same n-grams that are already used by the competitor websites or not. So you can read all these resources to understand the brand quality importance. And another thing is now search engine is showing the social media presence in the Google Search Console. So you need to optimize all possible social media resources for the brand. I think who has admit one guest. Okay, admit one guest. I
Leave it,
am answering
leave it,
you
leave it,
guys.
leave it.
Okay. So question three, I am familiar with the concept of keyword research. Okay, that's great. But in semantic SEO, there seems to be more emphasis on n-grams. Oh yes, we are already talking about how do I find n-gram opportunities and how do I optimize for both n-grams and keywords on one page. So n-grams actually are the combination of words. You can say it's your keyword, but the main concept of n-grams is to find more and more meaningful and contextual phrases related to your target topic. So this is the main thing. If you are writing about best weight loss supplements, you need to evaluate SERP manually to understand what are the meaningful phrases available on the SERP results. Let's do it a quick, quick analysis. So I search for site quality score patent. Search engine bolded. This one can be used to rank search results. Can be used to rank search results. You can see apparently there is no connection between site quality score, patent search query, and ranking search results. But search engine knows The main purpose of this Google patent is to rank search results. So from the Google patent, it picks just the most relevant sentence and showed as a meta description on the search results. So this way you need to understand all the bolded things can be computed fully automatically. Okay, such quality score representing a measure of quality for sites. So it is the second Google patent that I mentioned from Navneet Panda, predicting site quality. And this patent, if you are serious about n-grams, you need to understand this Google patent, why n-grams are important, and why search engine corroborates n-grams presence of new websites with the help of already ranking websites. I wrote one I wrote many posts, social media posts regarding n-gram analysis, and I think I have one YouTube video regarding this n-gram analysis. I have a custom GPT where I input the HTML files of competitor pages. I upload all these HTML files in one GPT, custom GPT, and it gives me a table of n-grams found on all these websites, relevant n-grams, not random. So you can understand all these things from n-grams analysis. It will help you more. Yes, Anil, please.
Yeah, I have a question like if I am writing a topic on site quality score, and there is one note document which is talking about site quality score, or so should we create another document to support, like that another document title is predicting site quality, 5 tips to predict site quality, and our pillar topic is how to calculate site quality score.
Yes, as I have already mentioned that there are 90% chances search engine shows the related topics on the sub results. So sometimes these are the related topic suggestions from search engine that these are the related topics or the broader topics that can be covered in that broader topic. So I searched for one Google patent and search engine showed another one because it was related to site quality score. So I was searching for this Google patent, but search engine also showed that because these both of the Google patents have same end goal. End goal is predicting a website's quality based on some external signals that are dependent on the internal signals of the website. And whether we need to create another page or not, it is the most disputed area in semantic SEO, and we have a particular list of filters when to create a new page and when not to create a new page. You can search for core entity in this way, core tuber gober, and the second entity is query deserve a page. So Sir Core calls it query deserve a page. This is a concept. How to create several pages versus merge queries. Yes, that's a very good post. I think it is my post. Why it is not Sir Core's post? So I remember he has used QDP abbreviation for that purpose. Query deserve page. Oh yes. So here are the posts from Sarkore regarding when to create new page and when to merge topics in another page. So my post, you can read my post and you can read Sarkore's post and it will help you a lot. And then I hope Lulu, you are satisfied with these answers. So apologize for not going into much detail. We have shortage of time. And Kahuna is looking at me. I am caring so much. Question number 4. When building a new page or updating an old page, how do we decide the boundary of a knowledge domain to avoid overexpansion? Aha, that's a very complex topic. And here you need to understand your topical borders. So, what is the deadline? What to include in this page and what not to include in this page, and what needs a separate page. Again, formula is simple. Query deserve page. You need to augment your context. You need to augment the user intents. What user intents need to be covered in same page and what user intents need to be covered in separate page. So it all depends on your subject matter expertise. When we will be creating topical map practical session, there will be a huge discussion on these topics, when to create a separate node and when to merge it in the another topic, and Kahuna calls it sub-based clustering, and we call it node finalization. Which node is finalized as a separate node, as a separate page, and which node is not a node, which topic doesn't need a separate page, it needs to be merged in another page. And if I explain all these things here, it will be a longer discussion, and all these things without practical will be difficult to understand. So we will see these practical insights while creating topical maps in much detail. Yes, Kahuna, please.
Uh, on Thayir's question, can you show the document?
The questions?
Yeah. So in Thayir's case, I think it's more about contextual domain than knowledge domain. Since if you talk about knowledge domain, then you are most probably getting into the central entity case, which is more topical map oriented. In the case of contextual domain, you have to look at the query network to decide which contexts are relevant and what's the boundary for that particular topic. So that's what we call the topical border, where one topic ends and the next one starts based on semantic distance between different contextual domains and query semantics, as we will discuss in the next session, which we will see how it happens. But just for the tip, I would just say do not go, if you are in doubt, then don't go in too much detail or too much depth in your content, because eventually you are just competing against the competitors that you have. You are not expected to cover it 100%. There is no score for perfection here. It's more relative. If you beat the guy who is ranking at top, if he's ranking with the spammy content or something of a low quality, you can easily beat it with 60, 70, 80% kind of coverage. Okay. So that's the thing. And yeah, as I explained in the best food for an aging golden retriever, you might have seen that we were still talking about all the different conditions and dietary requirements for that particular dog, not really focusing on why he's getting old or what's the average age of the dog and all those different contexts, which was not relevant for us in that domain. Okay, that's all.
So we have answered four questions, and 8 questions are left. So Kahuna, we have time for these answers, or we can answer this in separate videos, or
I think we
record
can
separate
do it.
videos for the users.
Maybe record separate videos or maybe answer
Yes.
in text. Uh, all is fine.
Yes.
We have already
That will be
published
great.
4.5 hours.
Yes. Yes, exactly. So that's
I
why
will
I
stop the
I
recording now.
thought to stop. Yes.